Okay, welcome back. We're on chapters 3 and 4 in the big book. So, chapter 3 is on access control and rootly powers. So, the part of the problem is a lot of people have kind of strange misconceptions. Access control, providing some sort of a way of preventing people who are unworthy of getting access to stuff, that is not the same thing as security. That's just one piece of security, right? Okay. So, believe it or not, there's an awful lot of third-party type of access control things that you can have, and there's the application programming interfaces, the APIs that programmers use to be able to provide all sorts of custom ways of doing security in Linux. Quite frankly, Linux's choice for the way it does controls for accessing files is not all that good. I mean, it was pretty good in the day. It was pretty remarkable, but pales in comparison to some of the things that Windows can do. So a lot of people just don't use the built-in one. They just have some sort of an add-on that allows you to do more. But we're not going to be talking about those. We're going to be talking about just the stuff that comes out of the box. Okay. So, on page 66, they talk about the standard UNIX access controls. And so they talk about some of the rules that you have to follow. Basically, the thing, it depends on which user and group you're in. Okay? So an object, almost always when we say object, we mean file. A file is where the permissions are stored. So in other words, there isn't a separate storage container which contains the permissions. I mean, if the file is there, that directory entry contains the information about who the user is and the owner is and what the user permission and the group permission. You've seen, right? You remember all the stuff about, if you do the long listing on an ls command and you get the RWs and the dashes and the R's, all that stuff, right? So all that is all about, built into the file is who has read permission, who has write. Just as a reminder, you own the objects that you create. So if I create an object and I'm currently logged in as Emmett Gray, then those objects have the name of Emmett Gray. Now, the root access, in our case we use sudo. A root is okay. If I was to do less on etc. password, one of the very first lines in there is root. So root is the name of a user. It's the name of a user. It's the user that has all power. So root can act like any owner. Okay, you can substitute for the owner. And then some things, obviously, only root can do. For example, when we go and get updates, we have to do a sudo thing. If we want to install something, we have to do the sudo thing. We want to mount something, we have to do the sudo thing. So that kind of makes sense, right? So the architecture of Linux is kind of weird in that everything was kind of designed as a file in the file system. I mean, all devices like keyboards and mice, as far as the machine is concerned, those are files. I know, it sounds a little weird. Everything is a file. So therefore, everything has the possibility of having permissions set on a keyboard and permissions set on a mouse and those kinds of things. That's kind of odd because everything is a file, everything has permissions. So it's kind of sort of cool. Okay. So we talked about this before. I'm going to do the ls thing one more time. Okay, so the first column is the directory and permissions, and the second one is the link count. The third one is the owner, and the fourth one is the group. Cool. All right. So every file has both an owner and a group. Now we've been using etc. password to get a list of all of the users, right? We've been doing that a lot. Well, there's another one called group, which is where all the groups come up. Okay, so all the groups. Now, this is where it gets a little weird. The system doesn't actually use the names. For example, it doesn't say Emmett Gray group is 1000. So it doesn't actually use the words Emmett Gray. It actually uses that user ID or group ID, the UID or GID. So behind the scenes, it's just numbers. Now, having said that, let's just suppose for a second that I am user 1000. And I'm a fairly high-ranking guy in the organization, and you've been granting me lots and lots of powers, like the ability to run the sudo command, okay? And then I get hit by a bus, and you take me out. And then someone else comes in, and they get assigned the exact same number. They get assigned 1000. Now, remember, the machine doesn't know, right? The machine doesn't know what the name is. They only go by the number. So that would be bad. So this junior person finds out, hey, oh my God, I got SU power. I can do anything in this system. Okay. Because it only deals with the numbers. By the way, the system is designed so that if you delete a user, it'll never reuse that person's user ID over again to prevent that scenario I just described. Okay. So on page 67, they talk about process owners. Remember, everything is a file to include a process. Okay. So the person who has created the process, in fact, I'm going to do one. I'm going to go ahead and do the tree command and like that. Remember, should take a long time. I'm going to use a control Z to stop it, not a control C because that would kill it off. I want to use a control Z to stop it, and then we can run the PS command and see what's going on. So I'm going to do that. Okay, so I've stopped it. I haven't killed it. So now if I do a PS, it's going to show me, my shell, because that's the root, poor choice of words. That's the top of the process tree for me. The tree command, which is the one we just stopped. And then, of course, I'm running PS, which is what it just said. So since I started this process, I can send this process signals. And I can change its priorities. So for example, let's say I started this guy and I realized, oh my goodness, this is going to take forever. I can actually go in and tell it, well, this is not all that important. So I'm going to be nice and I'm going to reduce the scheduling amount. So this becomes a background task. And so other people who are doing important things can have their stuff run faster because mine's not all that important. And it's perfectly okay for it to take a longer period of time. So the process owner can do that. They can send signals and they can change the priority. Okay, cool. Now here's where it gets a little complex. And so this is a little weird, so just kind of bear with me and kind of read that. You might have to read that section in the book maybe more than once. Okay, so basically there are three possibilities for your user ID. The first one is what's called the real account. The real account, the real ID, is what you use to log onto the system. Okay? Cool. And then the effective ID is one that you are pretending to be temporarily. For example, when we do the SU command, our real ID is, well, in my case, my real ID is Emmett Gray. But when I use the SU command or the sudo command, I'm temporarily elevated and I'm currently running that process as if I was root. Okay, so that's my effective ID. Now, 99% of the time, the effective and real is going to be the same, right? Kind of makes sense. The only time it would be different if you ran the sudo. Cool. All right. And then the third one is called the saved ID. And the saved ID is, how do you get, so let's say I'm Emmett Gray, and then I get elevated to root. I need some way of remembering which one I was, right? So the saved ID is the one you were before you ran the sudo command. Okay, so real ID, effective ID, and saved ID. Those are the things you have to kind of remember. Okay. So one more time, the root account. I'm going to do the, I'm going to just do cat on, etc. password one more time. Only if I spell it right. Okay, so root has a user ID of 0. This is not a coincidence. 0 is the beginning number in all the computer science. You don't start counting at 1, you start counting at 0. So 0 is the user ID of root. Okay, now we've already seen lots of things about what only root can do. There's a bullet list on page 68, the things that it can do. So, as all this stuff makes sense. This is absolutely the same as a list of things you would think that only the administrator could do in a Windows world. So in the Windows world, can you set the clock? Can you create a device? Can you install software, right? That kind of stuff. So that's what this one says. Creating a device, setting the clock, shutting down the system. And you, wait a minute. I have to be an administrator to shut down the system? I don't remember using sudo. Well, kinda. Baked into the shutdown command is what we call the set user ID bit, so that when we run the shutdown command, it automatically elevates it to the power of SU. Okay, I'm just saying. Anyway, that is a little weird in the world. It just makes it easier for you to shut down the system or reboot the system. But as long as you're in the SU group, you don't actually have to type SU. Okay, so we talked about how identities can be switched back and forth. On page 68, they talk about identity substitution. So basically what we're talking about here is that set UID and set group ID. Now, I'm going to do one just for the heck of it. I don't know how. Let me think about this a minute. I'm going to pick on something like test 2, okay? What I want to be able to do is I want to set test 2 so that when you run test 2, you're not running it as Emmett Gray, you're running it as some other user. And just for the heck of it, I'm going to have it set so it's run, the user that it gets run as is LP, just because I see it there. So there's two things you have to do before you can make that happen. One is you have to change the ownership of the file to make that, because I'm going to make it set so that the set user ID, well, I have to have the user ID set before I can set the user ID. Kind of make sense? I tell you what, let's go ahead and just do number test 8, because in that case, this thing is already set up there. So basically what I want to be able to do is do a change mode, right? CHMOD, okay? Now, if this was a file that I owned, I'd be able to change the mode with no trouble at all, right? So to give someone the effective ID, I would say, basically, I want the owner. Now, oh, wait a minute. In this world, using the symbolic, is it a U for user or O for owner? Which is it? And it says, well, man, you can't do that. Well, because I no longer own test 8. So I am going to have to sudo this guy. Okie dokie, I'm going to do the ls command one more time. And notice how it has a big S in that first column. So RWS. So that means the set user ID bit has been turned on for test. So if test was a shell script, when I ran the shell script, it would actually be running under the guise of the LP user, not the Emmett Gray user. Cool. Okay. So to change the group ownership, it would be G+S. And that way, you know, we're actually going to use that a little later on when we start having file shares. And I want like people of the engineering group and the sales group both to be able to read and write to a shared folder. I want to be able to have it so that when they create those files that the ownership follows. Okay, we're coming up on the 15-minute mark, so you know what's going to happen.